Okay, grade 12, let's revise number patterns. Number patterns are a critical part of the syllabus, and in matric, you're going to be looking at sequences and series. Now, in grade 10, just to recap, we looked at what we called the linear number pattern, if you remember. And basically, there were two methods that we used. the B plus C method, or the Tn is A plus N minus 1D. Now, those methods were developed in the grade 10 year. So if you go to Moby School lessons with grade 10 number patterns, we developed those two. Now, I'm going to use these two methods. Okay, and this method is going to be quite important because another word for linear is going to be arithmetic. Okay, an arithmetic number pattern, or sequence as they say. And we develop a whole theory. We also talk of other patterns like geometric, and in sequences and series that's going to follow, well, we're going to be dealing with number patterns. But I need to revise the grade 10 linear patterns quickly. Then also later on, we're going to be looking at the grade 11 quadratic pattern. Okay. And that we will do in the lesson that follows after this. But enough said, let's get into the linear pattern from grade 10 and have a look at that. So I've got an example 1 for you here. Okay, now what I want to do is I'm going to give you a number pattern. 2, 5, 8, 11, 14, 17 going on. And what I want you to do is I want you to show that it is linear. Show that the pattern is linear. Okay, so we're going to show that this number pattern is linear, and we're going to have to revise what do we mean by linear. Okay, and then in the second part of the question, we're going to find the general term, or the nth term, as they say. In other words, a formula that helps us to calculate any number, like the 100th term, the 1000th term. And then the C question is to find, using this formula, say the 100th term. Okay, now if you remember, back in grade 10, here's our number pattern, 2, 5, 8, 11 going on. How did you show that it was linear? Well, what is a linear pattern? It's going to have a constant first difference. Okay, in other words, term 2 minus term 1 is 3, and term 3 minus term 2 is 8 minus 5, which is 3, and they called that the constant difference 3. Or alternatively, we use the B plus C method, which I'm going to show you, or Tn is A plus N minus 1D. But the most important thing is we've showed that there's a constant first difference, so it's linear. Okay, now the next part of the question, B, says get the general term. Now, if you remember this, what did we do to get the general term? Okay, so we got our constant first difference. Okay, and then the one method. So the first method that we did in grade 10, and you can go back to grade 10 and do this, is that we basically circled those two terms there, and we called this B, and this one we called B plus C. And how did we then work out the B and the C? Remember that with a linear pattern, it has that general form. Tn is Bn plus C. So we want B and we want C, if you remember that. Okay, now, to do that, what we know, and this is important, we know that B is equal to 3. Okay, from there. We also know that B plus C is 2. But B, of course, is 3, so we substitute it into there. Okay, and then we solve for C. So we said 2 minus 3, bring that across, and the C is negative 1. So your general term would be Bn plus the C, which of course is, so that's Bn and plus the C, so it's 3n minus 1. So that was your general term. And I'm going to show you what we do with this general term in a moment. But there was a second method as well to get the general term, if you remember. It was a wonderful method. In fact, in matric, you're going to use this in sequences and series. It's a little formula that says A plus N minus 1D. Now, A is the first term, which is 2, and then the constant difference was 3. Okay, now have a look at that. In the number pattern, the first term is 2 and the constant difference. Another way of looking at it is that's the first term and that's the constant difference there. So what did we do? We go Tn is A plus N minus 1D, if you remember, and we said A is 2, n minus 1d. Okay, remember you can always go back to Moby School if you're struggling with what I'm doing here. I'm distributing, but the important thing is that there were two methods that we did in Moby School in grade 10, and you need to go back if you're not sure. Otherwise, if you're stuck, just follow the method of Tn as a plus n minus 1. We're going to come back to that when we start sequences and series. But anyway, this is just revision anyway to prime you for grade 12 sequences and series. Now notice it's pretty much the same. And then the third question said find the 100th term. Now the beauty of this general formula, okay, that we've got here, this thing, if you want the third term, have a look at this, 2, 5. If I said to you, what is the third term? Well, you can see that it's 8. That's the third term. But the nice part of this general formula, Tn is 3n minus 1, it helps us to get the third term. Look at this. If you sub in the n going into 3, well, 3 times 3 is 9 minus 1 is 8. Now we can use this to get the 100th term. Look at that. 3 times 100 minus 1, which is 299. Okay, and that is, of course, the two methods that we used in grade 10, and it's important that. Now I'm going to do another example just to clarify this, and once we've perfected that, it's time for you to do a practice example. Okay, let's look at a second example quickly. An example 2 here. Okay, I'm going to give you this number pattern, 7, 12, 17 and 22 going on. Okay, it's definitely linear because notice we've got and I'm going to ask you to show that it's linear. Show that the sequence, so that the sequence or the number pattern is linear. Okay, and find the general term Tn. Okay, then B, I want you to find T6, the sixth term, and C, I want you to find the 1500th term. Okay, now let's do this together. Okay, well, to show that it's linear, let's write them out, the terms, and see what we get. And look at this. Okay, you're going to get a constant difference of 5 there. Okay, and 17 minus 12 is 5. 22 minus 17 is 5. This is the constant difference. Because we have a constant first difference, of 5. Therefore, the sequence is linear. Okay, now to get the nth term, okay, what can we do? There's two methods. We're going to use the method 1, which is the B plus C method, and then we can also use a method 2, which is going to give us the Tn is a plus n minus 1d method. Okay, so let's do the B plus B method. Well, how do we do that? We'll circle those two, and that would be B and B plus C. Okay, grade 10. Okay, so what did we do? We said, look, B is equal to 5, B plus C is 7. Okay, but we know that B is equal to 5, so it's 5 plus C is 7, so C is equal to 2, so the nth term is Bn plus C, and there we have it. Okay, now, if you look at this another way around it, would have been to say that the constant difference is 5 and the first term is A. Okay, so here in this method, we've got A is equal to 7 and the constant difference is 5. So Tn is A plus n minus 1d. This, of course, is what this method 2 you're going to use in matric in sequences and series. And in fact, we call this this linear pattern, we're calling it arithmetic in sequences. But it's good to know this, and I'd encourage you to learn method 2 now. Method 1 is great for grade 10, but we move on to more sophisticated methods in method 2. So it's 7 plus 5n minus 5 if you distribute. So Tn would be 5n plus 2, exactly the same as that there. Okay, now the next question would be find the 1000 or the sixth term. Okay, so term 6 is equal to 5 times 6 plus 2, which is 32. Okay, that's the sixth term, which it is. If you look at this here, if you keep expanding it, look here. If you had 7, 12, 17, 22, if we add 5, we get 27. If we add 5, we get 32, and that is your sixth term. But now, what is your, in number C, the 1500th term? That would be 5 into 1500 plus 2. And if we use a little calculator, let's see, it's 5 times 1500 plus the 2 gives us 75 0, 2. And there we've got it, guys. That's the linear pattern using two different methods. Okay, remember, if you've got a constant first difference, it's linear, or later on we're going to call it arithmetic. Okay, and we introduce other types of number patterns as well.